So in the last video, I was talking about the Fundamental Theorem of Calculus, and we talked about two very similar definitions that basically said the same thing, that definite integrals and derivatives are essentially opposites of each other. So I'm going to go back to that first definition that said little f is continuous on the closed interval a to b, where big f of x is defined as the definite integral from a, which is just some number, to x of little f of t dt. Notice f is going to be differentiable on the open interval ab, and the derivative of f of x is equal to little f of x. That's going to come in handy when I go ahead and try to do this problem over my shoulder. So find the derivative of f of x, where f of x is defined as the definite integral from 0 to x of the square root of t dt. Now, I'm going to pay attention very closely here. So the lower limit, the number on the bottom, is 0 in this case. Now, in the last video, I said it doesn't really matter so much this number, and it's true. But in this case, I had to be very careful. I could not put a negative number on the bottom because, remember, you cannot take the square root of a negative number because it gives you an imaginary answer. So make sure, again, this is either going to be 0 or positive. Other than that, doesn't matter. So upper limit has to be x. In this case, it is. So other than that, this is going to work out nicely. So I'm going to come back over here and look at this. We are looking for the derivative of big f of x. Well, in this case, it's little f of x. Well, where do I find little f of x? If I look back at that definition, it's this part. It's the thing inside the integral. So I'm going to come over here and I'm going to look. There it is. F of x is literally the square root of x. Well, that's the derivative of big f of x. So yeah, I know you're kind of looking at me going, that's really easy, Mr. Harold, and you're right. All I had to do was take this top part, the upper limit, and essentially plug it in. That's how it works. Just make sure, again, it's continuous because of the lower limit.